The other part of it is that it really reduces torque velocity for your longer laterals. Meaning the tool is making such small adjustments and being very smooth that it's easier to get casing the bottom or your packers to bottom, or it can help you with if you want a water line on. So it essentially gives you a better bore hole and you steer more exactly for geology. Now the algorithms, I had to do a training course last year on this, of how this does it is, it's amazing. It's a constant balance between a near bit inclination sensor, it's right here, and a gamma sensor that's back here, that constantly communicate with the tool that is reading where the pads are to make adjustments. Now, what really got us to the next level was the fact that our pads no longer were creating a force constantly until it met that trajectory, meaning it wasn't, creating 100% steer force down to get to that inclination. You would actually reduce it or taper it off, so that once it hit that inclination, it held it and didn't go past it. This is the same thing going on that, it's the near bit inclination. We do have the closest near bit inclinometer. Basically, it's a sensor that tells you what inclination you're at, how far you're off from 90, because that's typically what we're looking for. Does anybody know what the benefits of that is? Perfect. So you steer quicker. With motors, you're at closest 30 feet behind the bit. So you could steer out of zone or steer in the wrong direction.
What about using an ABI tool with the motor, then you're at the bit as well?
Yeah. That's a competitor. I don't want to bring that up. No, he brought an MBI tool, near bit inclination. Schlumberger has the best, and there's not a lot of them out there. It's essentially a sub with an inclination sensor in it that can tell you where you're at. You can put that right below the motor. Problem with that, it affects your steering mechanics, especially with motors. And those can have issues with their reliability, meaning they're not as robust. So yeah, you can use those. I've only seen it run twice. I've been in scenarios it's run, but yeah, it's a good point. But for the majority of it, we like to say we do. It's all marketing. For rotary steer, we'll get the closest. Okay, so develop rotary steer roll. You spun the whole string from the top. Those pads worked out with the steer. And then we said, well, we need to drill faster. How do you drill faster? You spin the bit faster with more torque. Meaning you can take bigger bites with your cutters and at a faster rate. So what do we do for that? We put in a motor. So the motor, we explained that earlier, but these motors now don't have that vent housing. It's essentially just that power section with the set of bearings. And below it is either your steering unit or all those BHA components. There's a lot of different configurations between companies. So marketing names are up there, but basically we put motors behind these tools, behind these rotary steerable tools, in order to drill even faster. And it's made a huge step change difference. There's certain situations where you don't want a motor in a hole. There's numerous applications where you don't want a motor in a hole, but now, especially for land-based rotary steerable, motors are the preferred way just because you drill faster. I can tell you a lot of rig companies like having a motor down hole due to the fact that you don't have to put so much strain on your top drive of your drill pipe. So if you want to get comparable performance without a motor, you have to spin your top drive well over 100 RPM, sometimes 150, sometimes 200. Operators, or not operators, but rig companies like to keep that like 50 to 70, just because you're spinning something that fast, you can beat up quicker, and that's going to cost them. So we do get feedback from, and this isn't all for everything, we do get feedback from rig companies that they like the motor in the hole because it's easier on their equipment and helps their bottom line because it reduces their cost. This is just kind of bragging, not really bragging. This is a very high-end tool string. I hate seeing these personally because the chances of failure go up. They're very complicated, but we charge a huge amount of money for them, and they give the operator a lot of answers, especially the operator. So we call it like combo because there's 5 high-end elevating tools. They give an array of measurements that tell you numerous things. This is something you see in the North Sea, something in Angola, something in the Gulf, not so common here in the East. So, conclusion, and we'll lead into questions. You can see we covered the history of drilling overall, how it developed from, just spinning pipe with the out. We got into the motor technology a little bit, steering column, the 3 different modes of that, and then what the competitors had to offer on that. And then we built more exactly into auto track and let's see. So, the last bullet is something I like to reiterate because that's real world. Not everything's engineering. It'd be great if it was, but really it's dollars and cents. And so you have to be able to have your engineering and your intelligence turn into money. You have to you have to create products, apply those products in application specific way that makes you money. Same thing with the company. Any questions? Yeah.
How does your tool work in softer formations like salts, chalks, and consolidated sands?
What?
How does your tool work in softer formations?
Well, that depends. So softer formations can be problematic for rotary steerable tools because you have to push into formation. Now, our tools actually, we've been called out for a few jobs in soft formations because our pads have such a degree or such a range of how far they can push that they won't push into the formation lugs. They're just the right amount of force to deflect the bit and not go into formation. That's a good question. We do have that where, if it's too soft, you're gonna push it, it's like pushing the butt. And these little pads exert thousands of pounds of force. And if it's too soft, you're gonna just push into formation and not gonna deflect the bit. Does that answer your question?
Yeah, it does.
Anybody else? Yeah.
What happens when you have erratic RPM? Does it affect how your tool steers?
Well, it depends on the mode of erratic RPM. That's a very broad, because erratic RPM can be stick slip, where it slows up and speeds up. It can be severe stick slip, where there's actually this weird mechanic going on where the bit's going backwards. Now that's all at the hole. Now you can have BHA string whirl and BHA string stick slip, meaning you're having all these drilling dysfunctions up above. So it can affect it. What we have and all the competitors have is we call ours a VSS package, a vibration stick slip package, which is telling you it's basically telling you if any of those problems are happening down the hole. And then you, just through experience, depending on where you're at, you can mitigate or fix that problem. So I can tell you ours is the least susceptible to that. Power drives is the most susceptible due to their steering mechanic where they have a slapping action due to their flow diversion. So it can still steer, you just have to monitor it. The biggest problem with that is that you don't want to beat up your tool, because then your R&M costs, or your R&D costs, R&M costs are so high. So you can still steer, but you got to. Anything else?
Well, thanks, Braden.